What if I told you that in the middle of one of China's most brutal, lifeless deserts, farmers are harvesting millions of kilograms of food? No rivers, barely any rain, just sand in every direction as far as the eye can see. And yet, in 2023, this desert produced over 1.7 million kilograms of potatoes. This isn't science fiction. This isn't a government propaganda poster. This is real, it's documented, and right now, agricultural scientists from Saudi Arabia, the UAE, and beyond are flying to this desert to figure out exactly how China pulled it off. So today, we're going to answer the question everyone is asking. How did China grow food in a desert? And more importantly, could this change how the entire world thinks about hunger? Stay with me, because this story goes much deeper than potatoes. Part 1. The problem that ate a country. To understand why this achievement matters so much, you first need to understand what China was actually up against. And it was bad. Really bad. At its worst point, China had over 2.6 million square kilometers of desertified land. That's roughly 27% of the entire country, basically a quarter of China, consumed by sand, dust, and dead earth. Picture that for a second. An area nearly the size of Western Europe. Just gone. Swallowed. And this wasn't the kind of quiet, still desert you see in travel documentaries. This was aggressive, moving, expanding desert. Every dry season it crept further into farmland. Every spring the winds picked up and the sandstorms came. These weren't minor inconveniences. These were devastating storms. Walls of dust and sand that buried crops overnight, suffocated livestock, forced entire villages to evacuate. Hundreds of thousands of people were classified as what experts called ecological migrants. People who had no choice but to leave because the land under their feet had simply died. One of the worst culprits was a place in northwestern China called the Mu-Us Desert. It covers 42,200 square kilometers, bigger than Switzerland. For generations, it was known as one of the largest sources of dust in China. Every year, sandstorms from Mu-Us tore through surrounding villages, destroying crops and forcing families deeper into poverty. This was one of the most economically depressed regions in the entire country. But here's where the story starts to shift. Part 2. China decides to fight the desert. Around the turn of the 21st century, China made a decision, not a small policy tweak, a full-scale, national-level war on the desert. The centerpiece of this campaign sounds almost too simple: plant trees. Billions and billions of trees. But the scale of what China actually did is anything but simple. Since 1988, China has planted over 100 billion trees, specifically in degraded and desert regions. That's roughly 13 trees for every human being alive on Earth today. Alongside that, the government established 41 dedicated research and demonstration zones for desert management, and placed more than 26 million acres of severely damaged land under strict ecological protection, essentially giving the land time to breathe and recover. And it worked. Satellite images from the 1980s versus today show something that looks almost impossible. Green pushing back across zones that were once pure yellow. Chinese scientists gave this trend a name that felt almost like poetry: green advancement, desert retreat. But stopping the desert wasn't enough for some people. Because there was a group of engineers, scientists, and farmers who were asking a much bolder question. What if we didn't just stop the desert expanding? What if we made it grow food? Part 3. The idea that everyone thought was crazy. If you know even the basics of agriculture, you know what a crop needs: decent soil, reliable water, stable temperature, and organic matter in the ground for roots to hold on to. The Mu-Us Desert had none of that. The soil was essentially fine sand, loose, nutrient-poor, and incapable of holding water. When rain fell, which was rarely, it vanished almost immediately, draining right through without leaving anything useful behind. And rain itself? The Mu-Us Desert receives between just 250 and 440 millimeters of precipitation per year. For context, most productive farmland needs at least 500 to 800 millimeters annually to sustain crops without heavy irrigation. The desert was operating at a critical deficit before a single seed was even considered. Add in the constant wind, cold, dry, sand-blasting wind that could bury a young plant overnight, and you had an environment that agricultural textbooks would simply label not viable. And yet, in 2016, a team of Chinese scientists arrived in the Mu-Us Desert with a plan. Their first step wasn't planting food, it was something smarter. Using a technique called minimally invasive planting, they began carefully introducing drought-tolerant trees and shrubs into the desert, working with the desert's fragile surface rather than tearing it up. The goal was to stabilize the sand without causing more damage in the process. And slowly, plant by plant, it worked. Roots took hold. Wind speeds at ground level dropped as the vegetation created natural drag. Moisture began staying in the soil a little longer. The microclimate around the planted areas subtly shifted, just enough to matter. And that's when local farmers, watching these experiments from the edges, started asking out loud, if trees can survive here, what about food? Part 4, the $350 million bet. In 2018, the Chinese government decided to find out. A team of scientists was sent to conduct detailed soil and climate analysis across the Mu-Us Desert. What they found, honestly, surprised even the skeptics. Certain sections of the desert, particularly areas where past floods had deposited layers of fine, nutrient-carrying silt, showed just enough agricultural potential to be worth attempting. Not comfortable farmland, not easy territory, but within the outer edge of what science said was possible. That was all they needed. In October 2018, the local government committed $350 million to systematically convert sections of the Mu-Us Desert into workable farmland. And in 2019, the project launched. The team was a deliberate mix, around a dozen senior agricultural specialists paired with hundreds of local farmers who had spent their entire lives in this environment. That combination was intentional. The scientists brought data, technique, and resources. The farmers brought something no lab can replicate, a lifetime of watching how this particular sand moves, where water tends to pool after a storm, which patches of ground behave differently. They started with just 20 acres to prove the idea wasn't madness. Now, the water problem. Water is, and always will be, the central challenge of desert agriculture. Without solving it, nothing else matters. The solution the team landed on was ancient, not high-tech, not expensive. Ancient, flood irrigation. When seasonal rains swell the rivers running near the Mu-Us region, those floodwaters carry something precious, silt. Fine, nutrient-rich sediment scraped from upstream soils over hundreds of kilometers. Civilizations from ancient Egypt to Mesopotamia built entire agricultural empires on the fertility that controlled flooding left behind. The Chinese team engineered a network of channels and earthworks to redirect those seasonal floods onto their desert test plots in a controlled, orderly way. Every time a flood ran through, it didn't just water the sand, it deposited another thin layer of silt, slowly building up soil composition, cycle by cycle, season by season. It was patient, it was methodical, and it worked. The crop they chose? Potatoes. Selected deliberately because potatoes tolerate poor soil better than most staple crops. They need less water than wheat or rice. They grow faster, giving the research team more feedback cycles in less time. The first harvest came in, and the numbers were modest. 3,000 kilograms from 20 acres, averaging about 150 kilograms per acre. On normal farmland, potato yields run 800 to 1,200 kilograms per acre. So in pure output terms, the desert was underperforming significantly. But here is the line that changed everything. The potatoes grew in a desert, in sand that had no business producing food, with rainfall that barely qualified, in conditions that every agricultural manual said were impossible. They grew. The experiment had proven its core point. Desert soil, treated with patience and the right technique, could produce food. The proof of concept was real. Now came the question of scale. Part 5, from 20 acres to a movement. Once something impossible becomes possible, momentum builds fast. The project expanded rapidly. The original 20-acre test zone grew until potato cultivation covered nearly 4,000 acres of desert land. 4,000 acres of what had been lifeless sand, now producing food. The farming community around the project grew with it. Eventually, close to 12,000 farmers were directly involved, not as passive workers, but as genuine partners with real economic stakes in the project's success. And that partnership, between scientists and community, turned out to be one of the project's most powerful design decisions. The scientists kept refining the technique. Every growing season they adjusted planting density, water scheduling, soil treatment methods. They tracked which plots performed best and why. They ran the data, made changes, and ran the data again. The yield numbers climbed. From 150 kilograms per acre in those first trials, the project pushed steadily upward. By 2023, 5 full years of continuous iteration had pushed the average desert yield to 430 kilograms per acre, nearly triple the output of the first harvest. And across 4,000 acres, 430 kilograms per acre adds up to something remarkable. More than 1.7 million kilograms of potatoes produced in a single year from land that 5 years earlier was a sand dune. In 2023, China announced this result to the world. The response from the international scientific community was immediate. Part 6, what the desert actually became. Here's something most people miss when they hear this story. Growing food in the desert isn't just about food. Every potato plant that takes root in desert sand serves a second function. Its root system physically anchors the sand, stopping it from drifting. Its leaves create shade that holds moisture in the ground longer. When the plant dies and decomposes, it deposits a small amount of organic material into the soil, incrementally improving its structure for the next season. Do that at scale, hundreds of thousands of plants, season after season. And you're running an ecological restoration program in parallel with your food production program. Today, nearly 94% of the U.S. sandy land has been brought under effective management. That figure would have seemed like fantasy to communities living near this desert 20 years ago. The economic transformation has been just as significant. Before this project, the villages around the Mu-Us Desert were among the poorest in China. The combination of sandstorm damage, low agricultural productivity, and limited economic opportunity kept development stagnant and pushed young people out. As the desert transformed, that dynamic reversed. Farmers participating in the potato project began earning annual incomes exceeding $10,000, a figure that represented a generational leap in economic reality for families in this region. More than 30 surrounding villages reported measurable improvements in living conditions and community stability. People stopped leaving, some started coming back. The crops diversified too. Encouraged by the success with potatoes, farmers began experimenting with corn, drought-adapted vegetables, and other grain varieties. Each new experiment expanded the knowledge base, pushing the boundaries of what this reformed desert could support. What started as a scientific experiment had become something more, a working model of how patient investment and ingenuity can rebuild what was thought permanently broken. Part 7. The world shows up. In February 2023, something happened that turned this story from a Chinese domestic success into, well, a global conversation. A delegation of senior agricultural experts landed at the Mu-Us project site. They had come all the way from Saudi Arabia and the United Arab Emirates. These were not diplomatic tourists. These were working scientists and food policy specialists, people whose careers are dedicated to solving food security in some of the driest environments on Earth. They came to study the irrigation infrastructure, the soil treatment process, the community integration model, how it all fit together. And honestly, they came with urgency. Because for countries like Saudi Arabia and the UAE, this isn't academic. Both nations sit deep in the Arabian desert, with rainfall averages among the lowest on Earth. Both rely heavily on food imports. Both face growing populations that will demand more food in the decades ahead. The ability to produce meaningful food volumes domestically, in their own desert, is a strategic national priority, not just a theoretical exercise. Their visit to the MUUS project signaled something important, that China had built something genuinely worth the flight. And they weren't alone in paying attention. There are roughly 46 countries classified as existing in arid or hyper-arid zones. Many of them contain some of the world's most food-insecure populations. The UN Food and Agriculture Organization estimates that around 820 million people on Earth still go hungry. Climate change is projected to expand desert zones, reduce freshwater availability, and intensify droughts over the coming decades, making food security harder, not easier, for the most vulnerable communities globally. In that context, a proven method for converting desert into productive farmland is not just a feel-good story. It may actually be one of the most important agricultural developments of this century. Part 8. The human story inside the numbers. Statistics are useful, but they don't tell you what it actually felt like to live through this. The villages near the MUUS desert had been fighting a losing battle for generations. Every year the sand came closer. Every year more crops were buried. Every year more families quietly packed up and left for the cities because there was simply no future in staying. The first time farmers walked out onto those 20 test acres and pushed potato seedlings into desert sand, there was no guarantee of success. The scientists had their data and their projections, but this was still the desert. The desert had always won. And then the plants came up. There's something that shifts in a community when it sees with its own eyes that the thing it was told was impossible isn't. When you reach into sand that was a dune 5 years ago and pull out a potato, real food from that ground, it doesn't just feed you. It changes what you believe is possible. That psychological transformation runs as deep as any agricultural data point. Communities that believed their only future was elsewhere began to reconsider. Young people who had been planning to leave for the cities started asking different questions about what a life at home could actually look like. Farmers who had spent their careers in a defensive crouch, protecting what little they had from the advancing sand, found themselves going on offense for the first time. That shift in belief is quiet and hard to measure, but it might just be the most durable thing this project produced. Closing. A world that still has room to grow. In 2019, a small team of farmers and scientists stood on 20 acres of desert sand in northwestern China and made a bet that most of the world would have called foolish. By 2023, that bet had paid out 1.7 million kilograms of potatoes. Today, Saudi Arabia and the UAE are studying the model. Other nations are watching. And the deserts of the world, which once seemed like permanent boundaries on what humanity could achieve, are starting to look a little different. Because here's the truth that the MUUS project forces you to confront. We have been treating desert as a destination, as a place where possibility ends, as proof that some land is simply beyond saving. But 12,000 Chinese farmers just proved something different. They proved that with patience, science, and a community willing to do the hard work, the desert is not a destination. It's a starting point. The world is running out of easy agricultural solutions. Climate change is making more land more difficult to farm. The global population is still growing. And yet, somewhere in the sands of northwestern China, there are 4,000 acres of former desert producing food. And the scientists who built that haven't stopped yet. The question this story leaves you with isn't really about potatoes. It's about what else we've given up on too soon. If this story made you see the world even slightly differently, that's exactly why we make these videos. We dig into the stories that matter, the breakthroughs that don't always make the front page, the human decisions behind the headlines that end up shaping the future. If you want more of that, hit subscribe, turn on notifications, and, hey, drop a comment below. Do you think this desert farming model could work in your region of the world? We read every single one. See you in the next one.